So let's take a look at the next page, which gets into triangles and quadrilaterals specifically. So these are the primary polygons that you'll see out in the world, so to speak. Now, if we're looking at triangles to start with, we can analyze them based off their angles or on their sides. So we have three types of each group of triangle. So in the first case, if we have all angles acute, it's aptly named an acute triangle. So it would look just something like this. You know, nothing too fancy. But again, all of the angles have to be less than 90 degrees. If we had one right angle, then we would have something that looks like this. And again, we'd want to put that right angle in the corner. So that would be a right triangle. And then our last one would be obtuse, and you guessed it, it has an obtuse angle in it. So we'd have something that looks like this. Oops. So that would be our obtuse angle there. Pretty original, right? Now, for identifying a triangle based on its sides, now we have, again, three categories. So if no sides are equal, it's called scalene. So where they got that name, I'm not even sure. But it actually looks very similar to our acute. You could draw it as an obtuse or a right as well, but most of the time you'll see it look something like this. And really to signify that the sides are different, that there's no sides equal to one another, we'll use that dash method we talked about. We'll put 1 dash, 2 dashes, and 3 dashes. So that really signifies that the angles are different, or excuse me, that the sides are different. When there's two sides equal, then it's called isosceles. So that would look something like this. And again, I'm going to use the acute triangle to kind of illustrate it. And so if we had 1 dash in those two sides, and then 2 in the third one. So again, just to really signify that those two sides are the same. And then the third case, which you've probably heard of, is an equilateral triangle, and that's when all three sides are the same. So they all get a single dash. So that would be for triangles. Now, the one kind of question you might get asked or you might want to consider is something like, could we have a combination of these two descriptions? And so something like, could there be an isosceles right triangle? What do you think? An isosceles right triangle. Well, the answer to that is a yes. So if you've been thinking about it, there is a way to make that happen. And it would be if you have your right angle be in there, and then you have these two sides be the same. So you got your right angle and it's isosceles as well. So you can have some combinations of these two descriptions. Not always, but a lot of times you can. So that's just an example of that. Okay, so we're going to kind of look at the next group, and then we're going to look at some properties related to them. So the next group of polygons we're going to look at are quadrilaterals. And remember, quadrilaterals are four-sided. Now, the one thing that's not in here is the first type of quadrilateral, which is a general quadrilateral, which has no relationships between any of the sides, no relationships between any of the angles. So if I wanted to just kind of draw that real quick, I'm just going to section out this little corner here. If we wanted a general quadrilateral, it would look something like this. So again, we don't want any of the sides to be the same length, so that's important. So Now you're probably seeing it looks kind of like a kite. And it does look a little bit like a kite, but technically all the sides are different length. And all the angles are different as well. So in a kite, there's some sides that are the same length. So like these two short sides would be the same length, and these two longer sides would be the same length. So, and that's not the case here. So that's why it's a general quadrilateral. Kite is another type of quadrilateral, but we're not going to get into that. So, but what we are going to get into are trapezoids, which is the next step up from a general quadrilateral. So a trapezoid is a quadrilateral with one pair of parallel sides. So that would look something like this. So we need two sides that are parallel to one another. So that's going to be the top and the bottom here. Or in a lot of textbooks, they call those the bases of the quadrilateral. So again, those sides are parallel. The other two don't have any kind of rhyme or reason. They just kind of go out. Now, if we put a little bit more structure to a trapezoid, then we're going to get the next quadrilateral, which is a parallelogram. So now a parallelogram is a quadrilateral with two pairs of parallel sides. So if we had that same starting point like this, now we're going to have a pair of parallel sides. And then you got the sides like that. So think of it like a tilted rectangle or something like that. Because I'm pretty sure you know what a rectangle looks like, right? Well, if you don't, that's what the next shape is. So the next shape is a rectangle, which is a parallelogram by nature, but it has a right angle in it. So that kind of just stands it up straight. So we can draw those pretty quickly. Now it just says a right angle in it, but by definition or by proof or by whatever you want to call it, if one of the angles is a right angle in a quadrilateral, especially, or excuse me, in a parallelogram, then it forces all of the angles to be right angles in that parallelogram. So that would be our rectangle. The next one after that is a square. And we already drew a square before, but let's just draw it again. So again, all four sides are the same length. And of course, it's got that right angle in there, which makes all of them right as well. So by definition, it is a rectangle, but it has all the sides the same length. And then the last one is going to be the rhombus. And the rhombus is kind of like a square because it has all sides the same length, but it's a parallelogram, so it means it doesn't have to have a right angle in it. So think of it like a square, but tilted. So and again, I didn't draw that in, but I'm going to draw it in here. Put those dashes in to show all the sides are the same length. So that would be your rhombus. Now, what kinds of questions would you be asked about these? Well, I'm glad you asked, because a way we can kind of relate all of these quadrilaterals is to use like a little flow chart, a little tree diagram type of sorts. At the top of the chain, so to speak, is your square. That's the most specific quadrilateral because it's got all those right angles, it's got all the sides the same length, so it's the most specific. From there it branches and it goes down to a rhombus and a rectangle. So that's the next step down of specificity. It's not quite as specific as a square, but it's more specific than what's below it. And what's below it comes back together, and that's the parallelogram. So the parallelogram is below that, And then below the parallelogram is the trapezoid, which is the least specific out of those different specific quadrilaterals. So, if you were asked the question, is a square a parallelogram? The answer would be yes, because it flows down. So the square flows down through the rectangle down to the parallelogram, so a square is a parallelogram. But if I reverse that question and said, is a parallelogram a square? The answer is no, because you can't go uphill. You can't go upriver, so to speak. And you could do all kinds of questions like that. So is a rhombus a parallelogram? Yes. Is a parallelogram a rhombus? Not necessarily. It could be, but it's not always. A square is always a rhombus is always a parallelogram is always a trapezoid, because it has at least one pair of parallel sides. So is a trapezoid a parallelogram? No. Could it be? Well, it could be if you change the shape a little bit. So it's an interesting little diagram just to kind of help relate those different shapes. And I think there's a question like that in the homework, so keep that in mind. All right, well, I'm going to stop there, and then we'll continue with some properties of triangles that will be important for some examples we're going to be seeing. So see you in the next video.